the data science. So let's get started. So first of all, we need to import the libraries from the to do this project. So we're gonna first start from the linear algebra. We're gonna import the numpy library. After that, we need to data processing. So we're gonna call the pandas library. After that, we need a visualization for this project. So we're gonna import the matplotlib.pylot libraries, and after that we also need one more libraries as the Seaborn library to do the visualization. After that we need convert our object data types, so we're gonna need that library too. So we're gonna import the pre-processing library from the we're gonna import the label encoder library from the pre-processing. After that we're gonna need a logistic regression from the sklearn, so we're gonna import the logistic regression library also. After that we need to splitting our dataset into two things. One is a test, the second one is a train, so we're gonna import the train and test split library also. After that the last one is gonna be confuse matrix, so we need to do some matrix on this project, so we're gonna import that library too. As for us, we're gonna call that confusion matrix library. After that we're gonna need to import our database from the data CSV file, so we're gonna import our CSV files. You already know that I already import the CSV file over here. So after that we're gonna just run this file, and we're gonna read the data set. So after that we run the files, we're gonna see that all the database from the CSV file, you can see the ID, the clump thick, the unique cell size, cell shape, everything that are in the file we're gonna see over here. After that we're gonna do some summary of the data set, so we're gonna write down dataset.info. After that we're gonna run it. If we can see everything about the summary of the database, I think whatever the column, the data types, and if there is a null or not the data types over here, so we're gonna see everything of the information about the data types. After that we're gonna get down for the visualization. The first thing we're gonna do that plotting the histogram. We're gonna create the grams for the data cells. So first of all we're gonna print out the unit cell size and unit shape size. So we're gonna call this method to size the unit cells, and after that we're gonna need the shape size. We're gonna need the shape of the database, so we're gonna call this method to measure the shape of the database. We're gonna run that. After that we're gonna create the histograph for our database. So we're gonna recall this method plot.hist. We're gonna go to the size, then after that we're gonna go to the shapes. After that we're gonna put this function we're gonna put this condition over here, plot.legend upper right, and after that we're gonna show the chart over here. After that you can see over here, so you can see we have the chart. The blue one is gonna show us for the cell size, then the orange one is gonna show us for the cell shape. After that we have a plotting and join point. After the first one we're gonna create a join point. So for that we're gonna call the SPN library. So we're gonna do that over here. We're gonna call the SPN library SPN.joinPlot, and we're gonna write down this condition in the brackets over here. After that if we run this condition, we're gonna see this type of data. You can see the cell shape and everything over here. After that we have the data cleaning. As the first one we're gonna sorting out the missing value rows in the descending order. So what we're gonna do, we're gonna create this condition to list out all the missing value rows that we have in a database. So after that if we put this condition on a run, we can see that we have 699 length about the database, and if we have, and there is no missing values present in the given database, so we don't have any kind of missing value rows over here. After that, we're gonna see if we're gonna check if there is any row having all the value missing or not. So for that, we're gonna use this method over here, dataset dot is null dot all axis is equal to 1 dot sum. So after that, we're gonna run this condition. As you can see over here, we have 0 rows that have any kind of all the value missing. After that, we're gonna check if they have missing values in a column first. We already over here, we can see that we check on the if we have missing in a row. Now we're gonna check if we have missing values in the columns. For that, we're gonna do the same thing up we can do in the row. So we're gonna call the data set dot is null is sum. So we're gonna after that, we have this kind of columns if we have missing values or not. So over on from this result, we can say that we don't have any kind of column that we don't have any value or not. So after that, we have data processing. We're gonna do the data processing. So after first of all, we're gonna do that, like if we have any specific ID or not. So we're gonna see that drop the column ID because there is no role in prediction. If we're gonna say that if we have any ID, there is no role, so we're gonna drop that. So after that, we're gonna see that run it. As you can see, we don't have any kind of ID that gonna drop because we have all the columns and row are we have all the IDs in a running role prediction. After that, we gonna create a value in the database and everything. So first of all, we're gonna treating our values as a question mark in a database. Over here, you can count 1 and total count 1 because as you can see, I put on here 1 because like after that, if we use a if condition over here, we don't need any kind of error on our project. So we just put out over here the count as 1 and total count as 1. So we're gonna do the basic out of some database, then if there are any question mark signs are present or not. So we're gonna use the for method to determine that if we have any kind of rows they have a question mark sign in a database or no. So for that, we write down this method over here. After that, we're gonna print out the numbers of question mark values if they have or no. So we're gonna write down this for both count or total count. After that, we're gonna calculate the percentage of the lost values. As you can see, if I put it over here as like a 0 and 0 value, so and I run this method over here, I get the question mark because like we have a error over here. And if I can see that, where is it? Yeah. As you can see, like there is no definition for the we can there is no such rules that we can divide 0 by 0. So we're gonna put down 1 over here, and we can run the code again. So you can see that there is no error. So we need to there is no error in a calculation for presentation. So we're gonna write down is over here is the 1, so we don't get any error. After that, we're gonna print out the we got the lost value over here by select how many lost value we have or no. After that, we're gonna print the dimension of the database. So how many dimension how we have in a database, you can see over here. After that, we're gonna use the for method to do the accurate dimension calculation over here. After that, we're gonna print some dimension in the database. So this gonna give you the perfect accurate data for the dimension. So you can see over here we have number all the result over here. We can see the number of the question mark value is only 1, the number of total value is only 1, the percentage of lost value is the 100%. The dimension of the data set before the removing the question mark values is gonna be 683.11. After the removing the question mark values is the same thing, so we can assume that we don't have any question mark value in our database. After that, we gonna transform our object type column in a database. So we're gonna use this condition over here, d types. So the directory database dot d types. So for this, you're gonna use the for method for converting our objective types. After as you can see, we use our label encoder libraries to convert our objective data types. You can run, so you're gonna pass through. After that, we're gonna print our database to observe how first data to verify the changes. As you can see over here in the first various, you can see all the changes we have made so far. After that, we're gonna check the whether all the data points of the database is numerical or not. So you can see all the database over here. We have integer 64. All the data types over here also 64. 64 is gonna the condition is true. After that, we're gonna see that if since the class is a target label database, so we're gonna accept all the class to the separate variables. For that, we're gonna use this condition for the class to extract over here. So we're gonna run it, so it's gonna remove all the class from the database. After that, we're gonna feature the database X and labels for the database Y. So what we're gonna do is X equal database columns dot values, and for the Y we're gonna database in class dot values. As type for the numerical type is gonna be pass. After that, we're gonna separate the X and Y into test and data train database. For that, we're gonna use that. We're gonna write down the X train for the X test, a Y train and a Y test for the features of the testing and everything. Over here, we're gonna define that X train, X test, a Y train, a Y test for the split the database. After that, we're gonna pre-processing our standard scalar over here. So we're gonna normalize our database for training and test values in xtrain and xtest for the xtest. So we're gonna write down this condition for that, and after that we're gonna run it. It's gonna be passed. So all the changes we want to make is gonna made it on the database. After that, we're gonna create the model creation. So for that, we're gonna need a logistic regression library. So I import this from the logistic regression library. So we're gonna create a logistic regression model and train the model into model with the trained data. So for that, we're gonna call the logistic library, and we're gonna train the X train and Y train over here. After that, we're gonna evaluate the model with test data. So we're gonna print out this how many accuracy we have for the model. So after that, we're gonna run this one. As you can see, I have a 96.35% of model accuracy. After that, we have a model prediction. For this one, we're gonna predict the values for the using the given the test data. For that, we're gonna need a Y prediction is equal to model.predict x test. We're gonna predict the data from the x test to x test. We're gonna predict the x test data. So for that, we're gonna write down the model prediction is gonna be predict model. After that, we have a last one, the confusion matrix notation. For that, we need a confusion matrix using the predicted answer for the Y predicted. So against the true label values for the data set. So this one is gonna matrix for the Y prediction, the prediction data, and the Y for the Y test data also. So we're gonna use this condition confusion underscore matrix Y prediction Y test. After that, we run this one. We have this prediction data. This is the prediction data, and this is the test data. This is the test data. For that's it. we are end of all my projects. So that's it for the guys. I hope you enjoy this video. See you next time. Thank you. Take care.